All right, so MiniMax M3 just showed up and it's going toe-to-toe with Claude Sonnet 5. And the pricing gap alone is kind of wild. We're talking about M3 being roughly 8 times cheaper on output tokens. And that's a real number. Both of these models dropped recently and people are already running them in production. So the stakes are real right now. I'm comparing MiniMax M3 versus Claude Sonnet 5 across 4 actual tests with 15 verified sources and 0 vendor-funded charts backing the numbers. Honestly, the model that wins on coding benchmarks is not the one that wins on cost. So if you're running bulk API calls with long outputs, the cheaper model could save you thousands before you even notice a quality difference. So this comparison is for you if you're building anything that touches an API, whether that's a coding agent, a document pipeline, or just a tool you're running at scale. Pick the wrong model and you're either overpaying by a lot or shipping worse code completions. And both of those outcomes are fixable, but only if you know which trade-off you're actually making going in. Test 1 is long context document handling. The failure mode here is super specific. You load a 600,000 token document, your model hits a pricing wall halfway through, and suddenly your cost just doubled. Or the model takes forever to pre-fill, and your whole pipeline stalls. Both of those things happen, and which model you picked is the reason. Both models publish a 1 million token context window, so on raw capacity, they're matched. But MiniMax M3 doubles its price past 512,000 input tokens, while Sonnet 5 charges the same flat rate all the way to 1 million. On speed, M3 claims 9 times faster pre-fill than its prior generation. But there's no published Anthropic figure to stack that against, so I can't call it a clean head-to-head. Honestly, the speed claims from MiniMax are vendor reported against their own prior model, M2, not against Sonnet 5, so the 9 times and 15 times numbers are real, but they're not a direct comparison. NM3's API only guarantees 512,000 minimum, so that full 1 million context isn't always available. The gap on raw context capacity is smaller than the spec sheet makes it look. I was expecting M3's speed advantage to push it ahead here, but the pricing structure and the incomplete speed data make this one too close to call cleanly. It's a tied, one test in. MiniMax M30, Claude Sonnet 50, one tied. Both have 1 million windows, but different pricing cliffs, and that distinction matters a lot depending on where your actual input length lands. Test 2 is coding task completion. The failure mode is pretty painful. Your agent spins through a real code base, hits a tricky multi-file bug, and just gets it wrong. Now you've burned tokens, the fix didn't ship, and you're debugging the agent instead of the product. A few percentage points on a benchmark translates directly into how often that happens to you. What surprised me here is the size of the terminal bench gap. Sonnet 5 hits 80.4%, and M3 lands at 66.0%. So that's a 14.4% difference, which is the biggest measurable delta in this whole comparison. On SWE Bench Pro, it's tighter, 63.2% versus M3 at 59.0%. Bear in mind, these ran on different infrastructure and different scaffolding setups, so treat the gap as directional rather than exact. There's a quirk worth flagging. MiniMax M3's own SWE Bench Pro run used Claude Code as the scaffolding harness, so the coding agent wrapping M3 is literally Anthropic's tool, which makes a clean head-to-head read a little messy. And there's a community-reported 80.5% SWE bench-verified score for M3 that looks way better, but that's a different benchmark variant, not a contradiction of the 59.0% figure. Honestly, I was expecting a closer fight on coding given M3's size, but Sonnet 5 leads on every independent benchmark I could find. Claude Sonnet 5 takes this one, and that puts us at MiniMax M30, Claude Sonnet 5.1, one tied. The 14.4 point terminal bench gap is the biggest single delta in this comparison, and even with the scaffolding caveat, Sonnet 5 is the stronger coding model right now. Test 3 is API pricing. The failure mode here is you don't notice the cost until the bill arrives. You're running a batch job with long outputs, you pick the more expensive model because the benchmarks look better, and now you're looking at a bill that's 8 times higher than it needed to be. That's a real number, and it compounds fast at scale. I looked at the published rates, and the gap is pretty wild. MiniMax M3 at promo pricing is 30 cents per million input tokens and $1.20 per million output tokens, while Sonnet 5 intro pricing is $2 input and $10 output. So M3 is about 6.7 times cheaper on input and 8.3 times cheaper on output. Both are promotional rates that will go up, so take that with a grain of salt. But the gap is real today. I was expecting M3 to be cheaper, but not by this much. MiniMax M3 wins pricing, and that ties the overall score. MiniMax M3 won, Claude Sonnet 5.1, one tied. One caveat though, Sonnet 5 has documented prompt caching and 50% batch discounts that M3 doesn't publicly match yet. So for repeated context workloads specifically, Sonnet 5's real cost can get a lot closer than these headline numbers suggest. Test 4 is instruction following consistency. The failure mode is your agent ignores a constraint you set, or it drifts off task 3 steps into a multi-step workflow. and you don't catch it until the output is already wrong. In an agentic pipeline, one broken instruction can cascade into a mess that costs you way more to clean up than the original task was worth. What I found here is that the two models were measured on completely different benchmarks, which makes a direct comparison pretty hard. M3 has a vendor-reported MCP Atlas score of 74.2%, and Sonnet 5 has a press-verified humanities last exam with tools score of 57.4%. Those two numbers don't translate to each other, so I'm not going to pretend they do. The one concrete edge Sonnet 5 has is a documented effort parameter, low through extra high, that M3 doesn't publicly offer. Honestly, awarding a winner here would be fabrication. MCP Atlas and HLE with tools measure pretty different things, and M3's number is vendor reported, while Sonnet 5's comes from independent press analysis. On top of that, community testers have flagged M3's real-world latency on messy code bases as still unproven at scale, so the practical reliability gap is genuinely unclear right now. I was expecting one of these to pull ahead clearly, but the benchmarks just don't line up enough to call it. This one's a tie. So the final score stays at MiniMax M3 1, Claude Sonnet 5-1, 2 tied. Sonnet 5's effort parameter is a real practical advantage for developers who want cost quality control per request. But M3's 74.2% MCP Atlas score is interesting, and I'd want to see it replicated independently before reading too much into it. So here's where MiniMax M3 clearly wins. Pricing, it's 6 to 7 times cheaper on input and 8 times cheaper on output at standard context lengths. It's open weights, so you can deploy those 428 billion MOE weights on your own infrastructure, including Blackwell GPUs, which Sonnet 5 can't do at all, and it's natively multimodal on text, image, and video from the ground up, not added on after the fact. Now, here's where Claude Sonnet 5 clearly wins. Coding 63.2% on SWE Bench Pro versus 59.0% and 80.4% on Terminal Bench versus 66.0%, both from independent sources. Long context pricing is flat, all the way to 1 million tokens with no doubling tier. And it has documented prompt caching and 50% batch discounts that can cut costs dramatically on repeated context workloads, plus the effort parameter for per request quality tuning. Honestly, I was expecting a clearer winner overall, but this one really does split down the middle by use case. If you're doing high volume API work where cost is the constraint, go MiniMax M3. It's dramatically cheaper and you can self-host it. If coding task quality is what you're optimizing for, go Claude Sonnet 5. It leads on every independent benchmark, and its flat 1 million context pricing plus caching make it more predictable at scale.